So level 3 counting principles, it's very similar to what we did before in level 2, but just maybe slightly more complicated. Just a little bit more complicated. So let's have a look. So again, we're thinking chain of events all the time. You always have to think that you have decisions to make. You have to choose something first, and then you have to choose another thing, and then you have to choose another thing, and then you have to choose another, and then you multiply all the options. Okay, so you have, once you can fit the question to that kind of a strategy, you should be able to solve it. So this situation here, right? I have 5 books and 3 available spaces on my shelf. How many different arrangements of 3 books are possible on my shelf? So what I'm going to do is I'm going to draw out here. You have 3 positions. Okay? So these are 3 positions on your shelves. So you have 5 books and you want to fit them in there, and you want to know how many different ways can you do that with your 5 books. So look at the first position here. I'm going to put them down as position 1, 2, 3. How many options have I got from the first position? Okay, so the position isn't full. I have my books. I have 5 options. I have 5 books to choose from to fill that first spot. Okay, now I'm going to fill the second spot. How many books have I got? How many options have I got? Well, I've used 1 in the first, so that means I have 4 left over. And now look at the last position. Okay, so I've already used a book to fill the first position. I've used another one to fill the second, so 2 books are gone, which means I have 3 left. 3 options for here. Chain of events, multiply. 5 times 4 times 3, and the answer is 60. Okay? Example. I have 4 books. How many ways can I arrange them on my desk? So that means that you have space for all 4 books. It doesn't tell me I can only arrange 3. It tells me I can arrange them all. So imagine that I'm going to do it again. 4 different spots on my desk. Okay? So, first, second, third, and fourth position, and I have 4 books to choose. So when I go to fill the first spot, I have 4 choices of book. When I go to fill the second spot, I have 3 because I've already used 1. The third spot, I have 2, and to fill the last spot, there's only 1 left. So how many possible ways can I fill it? 4 times 3 is 12, times 2 is 24, times 1 is still 24. Okay, so there's 24 different arrangements. I could mix them up in 24 different ways. Okay. So there's this one. 10 people competing in a race. How many different arrangements for first, second, and third are there? Okay, so how many people could come first in that race? So let's have a look and see about that. So I have the first place spot to fill, second, and third. So if there's people running in the race, how many possible people could finish in first position? There's 10 possibilities, isn't there? Now I know that some people are going to be better than others, and they're probably more likely to win. But that doesn't matter. There's still 10 options. There's 10 possibilities. So how many possibilities are there for the second position? There's 9 because we've already had somebody in the first. And how many for the third one? There's 8. Now look at this. 10 times 9 times 8 is going to be a big number. If you don't multiply that out, that's fine. What you're doing here, you're showing me what we call the chain of multiplications. This is the chain of multiplications. 10 times 9 times 8. And that's going to be enough for most questions. And this works out to be there's 720 different possibilities for first, second, third. Okay, that's how many different. If you had 10 people and you want to fill the first, second, and third positions, that's how many ways you can do it. So remember, the chain of multiplications is what's important. Okay, again, right, this one, similar. 24 students in the class, and I have 5 desks at the front. So here's my first desk, 2, 3, 4, 5 of 24 students. How many different arrangements are possible? So I'm going to fill the first desk here on the left. How many choices have I got? 24 students to pick from, haven't I? Go to fill the second one. I have 23. You see how it's a chain? Okay, I have 23 because I've used 1 already. To fill the third desk, I've used 2 students to fill the first 2 desks. So that means I have 22 options. 21, 20, multiply. Okay, now look at that. That's going to be a massive number. So just leave it like that. That's your chain of multiplications. That's your answer. Now, we're going to have a look at one that's very similar, but it has a slight change in it. So I want to create a 4-digit code for my locker. How many such codes are possible? So if you're creating a 4-digit code, what you have to do is you have to choose a first number, a second number, a third number, and a fourth number. Okay? Now when we talk digits, digits are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 10 digits because we include 0. So don't forget that. So what this tells me is that digits can repeat. What I mean by that, if I choose 7 to be the first number, I can choose 7 again if I want to. I can choose 7 to be anywhere else. It's up to me. It's my choice. So what I do is I go, how many options have I got for the first position? I can choose anything from 0 to 9. For the second position, anything from 0 to 9. For the third and for the fourth, it's the same. And you multiply them, and that's actually going to be 10,000. Watch, here's a slight difference though. Slightly different. So in this case, I'm telling you that the digits cannot repeat. So if I choose to have 7 in the first position here, I can't use 7 again. So in the first position there's 10 options. Now how many options are there for the second one? Well, I can't use whatever number went in the first position can't be used again, so I've only 9 options left. And then I've used two digits, so I can't use those 2 again, so I have 8 and then 7, so it's 10 times 9 times 8 times 7. And again, that's your chain of multiplications, you can leave that as your answer. Okay? A couple of practice problems for you. So, I'll scroll through these, but you can pause them. Now remember, I'm expecting people to keep their notes well. Things need to be tidy. Keep the notes well, and you'll be allowed to use them in unit tests. I'm going to read through these anyway quickly. So the first one, how many ways can I arrange the letters of the word triangle? So you have the word triangle, you have those letters. How many ways can you mix those letters up? So you have positions to fill, and in this case you're going to have 8 positions to fill, and you're going to count how many options, how many positions do you have for each one. And in this case, we're mixing the letters up, so I can't repeat it. Okay, if I choose to have R in the first position, I can't have R in the second position as well because I've used the R. I'm using each letter once in this case. Okay, second one, you have 12 CDs, you want to arrange 6 on your shelf. How many ways can you do that? 20 students in the class competing in a race, how many different arrangements are possible to fill 5th and 6th position? Okay, you're not interested about 1st, 2nd, 3rd, 4th, 7th, 8th, 9th. You're looking at 5th position, how many ways could that be filled? And 6th position, how many ways could that be filled? And you're going to multiply. Now look at the last one. You want to create a 2-digit number at random. How many possible numbers are there if digits can repeat and if digits cannot? Okay, and that's level 3, counting principles.